David Smith here with another Flipped Classroom math video. A few tips before we start. Remember that you can slow down or speed up the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or try the problems before I explain them. Lastly, you could turn on the captions and read my words going along below the bottom of the screen. Okay, the lesson for today is about speaking scientifically, and this is basically about scientific notation. So if you've had chemistry, you should be pretty familiar with this. If it was a challenge for you then and you don't feel like you mastered it, here's your chance to do that. Okay, so let's take a look. Standard form is what they call it in our textbook, really just is scientific notation. Okay, and what it lets us do is write down and express very large and very small numbers in an easy to read format. Let's take a look at two numbers that benefit from scientific notation. You guys know about Google? And I'm not talking about the search engine and Gmail and all that kind of stuff. A Google is a number in mathematics. And a Google is just a 1 with 100 zeros after it. Now, would you like to try to write that down on a page? I mean, you could do it, but it's just crazy and it's not helpful. So there's a quick and easy way to write down a Google. It's just 1 times 10 to the 100th power. That's a Google, okay? Super, super easy. How about Avogadro's constant? Again, from chemistry. This is a number with a ton of digits. So let's write that in scientific notation. So Avogadro's number is 6.022 times 10 to the 23rd. And if you're in chemistry and doing a lot of calculations with Avogadro's number, you don't want to write that whole thing down because this means that there's 3 decimal places going out there. So it's like quite a bit of numbers there. Okay? So you might have already picked up on the form of scientific notation from these two examples. I'm going to state it in a general way. So it's A, which is some number, times 10 to the n. That's the power. Now there's a few rules for what A and n can be to be in correct scientific notation. A has to be greater than or equal to 1 and less than 10. Okay, so A has to basically be between 1 and 10. And n has to be an integer. Can't be a decimal or a fraction. Scientific notation requires that n is an integer. Now, one of the things we're going to lean on when we're working through this is the rules of exponents. So if you're shaky on those, I'm going to put a link to 1 or 2 videos that I've recorded for other classes that talk about the rules of exponents. So that is assumed prior knowledge, and your textbook has several pages that go through that. So you can skim that as another source for getting your exponent rules back into your mind so you can use them when you need them. Okay, so one of the things we're going to do with scientific notation is we're going to convert into it and out of it. So the first one I'm going to show you how to do is you're going to start with some numbers in scientific notation, and we're going to turn them into the numbers that they are outside. So what we do is we start here. We have a positive value for n. So that means we're going to add zeros to the right. So watch this. We are at 1, 5. That's our number. Okay, so we have a decimal in there, but what we're going to do is we're going to move that 7 places to the right. So 1, now when I keep adding a decimal, I have to add a 0 now. 2, 3, 4, 5, 6, 7. So this is 15 million. So pause the video and see if you can do this one. 7.23 times 10 to the 3rd. So give that a shot. Okay, let's see how you did. So what I'm going to do is I'm going to write my number. 723. Now my decimal is here. I need to move it 3 places to the right. So 1, 2. Now I need 1 more 0 for that last decimal place. Because remember, there is a decimal right there, including in that number. We just don't need to write it because there's nothing past it. Okay? So that's going from scientific notation to the standard number. I want to point out a few things. 10 to the 7th is pretty big, certainly bigger than 10 to the 3rd. And guess what? 15 million is quite a bit bigger than 7,230. Okay, now let's do the other way. A little more tricky. When you have a negative exponent, you move the decimal to the left. the same number of places as that number. So watch this. What I'm going to do is I'm going to write my 2, 4, 4. Now my decimal is going to move that way. So I'm here. Actually, you know what? I need a little bit more room. So let's put the 2, 4, 4 out there. My decimal is here. So I'm going to go 1, 2, 3, 4, 5, 6. So that's 0.00000244. So that is that number. Okay? I want to call your attention to something here. When you have negative decimals, you know you have when you have negative exponents, you know you have small numbers. The bigger that negative, the smaller the number. And this makes sense because this is a pretty tiny number, 0.00000244. Okay, now if you're feeling confident, pause the video right now and try this one. You're going from 2.15 times 10 to the negative 4 to a standard number. So pause the video and see what you get. Okay, so this time I'm going to start a little further over. I almost ran out of room on that one. I have 2, 1, 5, and I'm only going 4. Okay, so my decimal is here, so I start there. 1, 2, 3, 4. So that one is 0.000215. Okay, so check this out. This is more negative. This number's smaller. This is not quite as negative as this one, and guess what? This number is not quite as small as that one. Okay? So this is one of the benefits of scientific notation, is that you get the numbers that matter, the significant digits, right? Here we got 3 sig digs right there, and then the exponent tells you how big or how small the number is. So you can compare two numbers really quick. Plus it's like really easy to see. This is a pretty ginormous number with 10 to the 7th, and yeah, it's 15 million. Okay, now let's convert to scientific notation. And so check it out. Now we have these real numbers. We've got a couple tiny ones to start with, and then one very big one, and then one not so big one. So check this out. Okay, here we are. Now scientific notation is just going to have these numbers. So I'm going to go 1.61 because we know scientific notation says the number in front, the A, has to be greater than or equal to 1 and less than 10. So that's why we always put the decimal after the first sig dig. So 1.61. Now, how many places did we need to move the decimal to get into this form? So we were here, and we had to go 1, 2, 3. So that's 10 to the third, but is it positive or negative? Good question. We have a pretty tiny number, so that means if this number is bigger than this number, then the thing needs to be negative. And that makes sense, because you remember from the last conversion, when it was a minus, we moved the decimal this way. So if we move it 3 units there, we get back to there. Now I want you to pause the video and try this one, 0.023. See if you can do that. Okay, here we go. This one, again, I'm going to go into scientific note. I'm going to go into that decimal form. So my first number is always 1 all the way up to just a little less than 10. So this is going to be 2.3. Now, how many spaces did I need to move from here to get to there? And that's 1, 2. So this would be 10 to the minus 2. And this makes sense. This number is a little smaller than this one because it's more negative, and you can see from these two numbers that one definitely is smaller because it's 0.00 before we get our digits. This is just 0.0, okay? So this one's a little bigger. Both are still small, but this one's a bigger one. Okay, now let's try this ginormous number. Now, I like to separate my zeros by commas, so the first thing I'm going to do is group it like that. So we have 748 million right there. Okay, so now we know that we need to be 7.48 to satisfy the rules for that first number. So 7.48 times 10 to something. And now we know we're taking a big number and we're reducing it to scientific notation. So that exponent is going to be positive, and we can just count the spaces it needs to go from here to there. And that's 1, 2, 3, 4, 5, 6, 7, 8. So this would be times 10 to the 8, okay? And that makes sense, because if we convert this to regular numbers, The positive 8 means we're going to go this way, 8 decimal places, and that's going to add those zeros right back to that. Okay, now pause the video and see if you can put this number into scientific notation. Okay, this one's pretty straightforward. 69.7, that's pretty close, just not quite, because we need to be 6.97 times 10 to the something. Now, how many decimal places did we need to go from here to there? It's just 1. We're 69.7, this is 6.97. So that's going to be times 10 to the 1. And that's it. Okay, in this little segment, we're going to talk about scientific notation and the TI Inspire calculator. So if you have your calculator, what I want you to do right now is pause the video and go get it. Turn it on, make sure it works and all that, so that you can do some of these calculations with the calculator. We're going to enter this number, 9.28 times 10 to the third. Okay? So pretty straightforward. You're going to have to key in. There's 2 ways to do it. You're going to key in. You're going to press the 9, the decimal, 28, then locate this button. There's 2 E's on it. Press the EE button and press 3. Now let's talk about what the EE button means. It means times 10 to the. Okay, it doesn't have the exponent, but it means times 10 to the. So what you've done is you've typed 9.28 times 10 to the third power. Now the calculator is not going to show you scientific notation. The calculator is going to show you the number, 9280. The second way is a little bit more literal. Instead of having an EE button that means times 10 to the, what you do, same start, 9.28, then you just press the times button, then you press 10, 1, 0, and then you press the caret button. This is the the downward opening triangle. It's also the shift of the 6 key on your keyboard. It's called caret, but what it does in math on a calculator is it means the next number is an exponent. So you're going to type the caret and then the 3. So let's go over that again and talk about what we're doing. Pressing 9.28 times 10 to the caret 3. And the calculator, if you do that correctly, it's going to show 9280. Okay, so now I'm going to ask you to try something different. I'm going to ask you to type this first number and then multiply, so you're going to press the times in the middle, by this number. And you can type it in either way. Maybe you want to try both. Type this one in that way and type this one in that way, but I'll leave that to you. So what I want you to do is go ahead and type in 7.25 times 10 to the fourth times 4.9 times 10 to the seventh. And my answer shows up in scientific notation. So this one's going to give us 3.55 EE12. So this equals 3.55 it just shows up as 1E12. Now that's something that's interesting that you'll have to get used to. The button, this EE button, gives you scientific notation upon entry. However, in display, it's just 1E. So this is a good thing to make note of. Whenever you see something, blah, 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 with an E and another number, it means that something times 10 to the 12th. Okay? So that's how that worked. Okay, one last exercise and then I'll let you stop the video. I've got 3 columns. Here's the calculator style with our E. Remember, this means 2.1 times 10 to the 6th power. So calculator style here. Here we've got standard scientific notation here. And here we've got decimal. So I've put 4 numbers up here. 2 in the calculator language, 1 in side note, and 1 in just plain old decimal. Your task now is to pause the video and fill in the missing parts. So for example, this one is in scientific notation, in the calculator notation, write this in scientific notation, then write it in decimal. And the same for the next one. You're going to start with scientific notation, put it into calculator notation, put it into decimal, and so on. So go ahead and pause the video, take a minute, think about it, use your calculator if you need to, and finish that table up. Okay, let me walk you through that. Let's see how we did it. Okay, so going from calculator to scientific notation and back is pretty straightforward. This is 2.1 times 10 to the 6. So I'm just going to write 2.1 times 10 to the 6. Now this one, we're at a positive exponent, so we're going to move that decimal to the right 6 places. So here's 2, 1, my decimal's there. So 1, 2, 3, 4, 5, 6. And do yourself a favor and add the commas so that you can see clearly that's 2,100,000. Okay, now let's take this one and go back to the calculator notation. We've got 4.05 times 10 to the negative 7. So that's going to be 4.05 times 10 to the, that's the E, negative 7. Okay, so calculator, scientific notation. Now let's go over to decimal. So we have 405, and our decimal is here, and now we're going to go 7 this way. So 1, 2, 3, 4, 5, 6, 7. So that's 0.000000405. Okay? Now let's do this nice ginormous number. We know this is going to be 5.003 times 10 to something. So how do I get the decimal from here all the way at the end to the right after the 5? I'm going to put my finger at the end where the decimal is now and count. 1, 2, 3, 4, 5. I moved this way, so that's positive, is a big number, so we're going to go times 10 to the 5. Now once we have scientific notation, then it's easy to put it in calculator notation. We're going to have 5.003 E5. Okay? I think the calculator notation is perhaps a little confusing because strictly speaking, it's not really writing correct mathematics. It's using this E symbol to stand in for times 10 to the something. Okay, last one. 1e negative 3. That's going to be 1 times 10 to the minus 3. 1 times 10 to the negative 3. Now to go into decimal, we're going to write our 1, that's what we have, and we're going to go 3 this way. So 1, 2, 3. That's 0.001. Now that you've finished the video, take a moment to jot down any questions that you have so you can bring them to our next class and get some help. You can also watch the video again to perfect your understanding. If you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.